So since this question is based on projectile motion, what I would suggest is let's have a quick recap about the basics of projectile motion, right? And then we'll try to answer these questions based on the discussion. So we know when a body is in projectile motion, it can be expressed as a combination of two motions. One along the x-axis with velocity vx and other with along the y-axis with velocity vy. Or in other words, projectile motion can be expressed as vertical motion plus horizontal motion. Now what does this mean? This means that if you project an object with velocity v at an angle theta, right, it will always have two components of velocity. One which is the horizontal velocity and the other which is the vertical velocity. Okay. Now, as the object goes up, one thing remains constant, which is the horizontal component of velocity. So the horizontal component of velocity remains constant throughout. It remains constant throughout. But what varies is the exactly the vertical component. The vertical component, since acceleration due to gravity is always pulling it downwards, during the motion from point of launch O till A, acceleration due to gravity would actually pull down this object, and at every consecutive point the vertical velocity would reduce in its magnitude. Therefore, here the vector would be smaller, here the vector would be even smaller, and here the vector wouldn't exist at all. Now, after A, what happens is the acceleration due to gravity would try to pull this towards it. Therefore, it will result in an increase in velocity, and you could see that the magnitude of the vector is the same, the only difference being the direction. Now, we have the same magnitude of vector here, but so if you compare these two vector diagrams, the difference is both of them have a horizontal component of velocity and have an equal vertical velocity, but in the opposite direction. This is towards north, this is towards south. And then as the last one, we also have this component of velocity like here, right? And of course we can also say that the net direction of velocity, net velocity, would be something like this, and here we only have one component of velocity, which is the horizontal velocity. Here the net velocity would be like this, and here it would be like this. Okay, so this is the basic about projectile motion. Now what's interesting to understand here is this point A is very critical to us, especially in this question. Why? Because A is the maximum height, right? A is the maximum height, and in this height V, which can be written as root of Vx square plus Vy square, or say V at A, which can be written as root of Vx at A square plus Vy at A square, right? Okay, let me keep this discussion posted for a second. Let me just take you through so this is where I want you to make a note of things here. Okay, so what is the behavior of a particle, behavior of an object which is under projectile motion? When a body is projected at an angle from the ground at an angle theta, it follows a parabolic trajectory. Okay, this motion can be broken into two components. One, which is the horizontal component at constant velocity, since there is no horizontal force, ignoring air resistance. So this component, so the horizontal motion is constant in nature. Second one is vertical motion, which is affected by gravity, which causes the vertical velocity to decrease as the object rises and then increase as the object comes down. Okay, so if you have written down this observation, and if you were really concentrating during the previous the diagram, I think concepts would be clear by now. If you have not, or if you find recollecting projectile motion difficult, I just try to give you a brief recap. Okay, now let us go through each and every statement given to us here. So the statement 1 says the vertical component of momentum is maximum at the highest point. Now, again, if you are new to this topic, or if you feel that you need a recap, please make sure that you make a note of these things. So, for statement A, the vertical component of momentum is maximum at the highest point. See, at the highest point, the vertical component of velocity is 0, right? As gravity has decelerated the vertical motion to a stop at this point before pulling it back down, which means from this point, as the object is going up, right? As the object is going up like this, what will reduce? What will reduce? Let us see. What reduces is, this was the earlier vertical component. Now the vector has reduced further. The vector has reduced further, and here there is no vertical component at all. The gravity has decelerated the vertical motion, which means the magnitude of the Vy component is becoming less. To a stop, here it is 0, right? So at this point, I can write that, Vy is equal to 0. Since the momentum is mass into velocity and the vertical velocity is 0, the vertical component of momentum is also 0. Okay, which means statement A is incorrect. Now let me just, please make sure that you make a note of these things first, right? Make a note of these things and then we'll try to do it mathematically. So I can say that at the topmost point, the only velocity is Vx is equal to V cos theta, right? And Vy is equal to 0. Now we have Vx is equal to V cos theta and Vy is equal to 0. Now what is Py? Py will be equal to m into Vy. What is Py? Py is the linear momentum along the which direction? Along the y direction. So since Vy is equal to 0, we can have that Py is also equal to 0. Okay, I hope that makes sense. Very simple concept. Now let us go to the second statement. What does it say? It says that for a body projected at an angle with horizontal from the ground, choose the correct statement. The kinetic energy, oh, I'm sorry, okay, this was the question directly. The kinetic energy is 0 at the highest point of the projectile motion. See, the kinetic energy is 0 at the highest point of projectile motion. At the highest point, the object still has a horizontal component of velocity, which means it still has kinetic energy. Along which direction? Of course, along the horizontal direction. Only the vertical component of velocity is 0. Kinetic energy depends on the total velocity, and since there is still horizontal motion, or in other words, since there is some total velocity, kinetic energy would not be 0, and therefore the statement is incorrect. Let us try to understand that mathematically and graphically. So what we have here is when we have a projectile motion, right? When we have projectile motion passing like this, as it reaches the highest point here, say this is O and this is A. As it reaches A, we need to understand that at A, Vy is definitely equal to 0. Why? Because as I've represented here, the magnitude of this velocity vector along the y component, it diminishes to 0 at A. But what we also need to understand is at A, velocity along the x component is still equal to V into cos theta, right? Now, at highest component, what is kinetic energy is equal to? Kinetic energy at highest point h max or height max is equal to half m into V at h max square, half mv square. Now what is Vh max square? Vh max square is actually the resultant of Vx square plus Vy square. Now what is Vx square? Vx is V cos theta, Vy is 0, therefore V at h will be equal to root of Vx square plus Vy square, which is equal to root of V square cos square theta plus 0, which is equal to V cos theta. So V at h is equal to V cos theta. And therefore, what is kinetic energy at the maximum height? It is half into mv square cos square theta, and definitely this is not equal to 0. And why is it not equal to 0? Because V is not equal to 0, because m is not equal to 0, and because theta is not equal to 0. Okay, I hope that makes sense. Now, let us come to statement number 3. See, now this is one such point where I think conceptually a lot of students don't try to emphasize much on the concepts here, both in the theory part, and in the mathematical sense. Let us see the basic theory here. So the gravitational potential energy is maximum at highest point is what the statement says. Now the gravitational potential energy, which we can generalize as mgh, depends on the height h above the ground. Now see, this is the point where I would say concepts should be really strong. It necessarily need not be on the ground always. What I mean is there can be a zero reference chosen for this gravitational potential energy, which can either be the ground or which can, that is arbitrary. You can choose it anywhere along the plane. Now, at highest point of projectile motion, the object is at its maximum height. So when the object is projected from A at an angle theta with velocity v, it will travel like this, and slowly it will come to this maximum height b, right? And at the highest point, at B, the object is at its maximum height, meaning the gravitational potential energy is also at its maximum, this point. Therefore, C is correct. Now, let us just try to go through, let us try to connect the chapter gravitation and work energy power here. See, by the theory that we learned in gravitation, what is gravitational potential energy? U is equal to, it is mgr into h by h plus r. But since these projectile motion take place very close to the surface of Earth, I would like to repeat that point. Since this projectile motion takes place very close to the surface of Earth, we can say that when compared to the radius of the Earth, this height is really, really less, extremely less. And since it is extremely less, we can therefore approximate r plus h as r. And then what we get is, instead of r plus h, we can substitute that with r, and r by r becomes 1, and therefore u is equal to mgh. Now what is this h? In this specific example, we have considered h to be the surface of the Earth, but it doesn't mean that it always has to be the surface of the Earth. When you say that potential energy U is equal to mgh, what we need to understand is, when we use this formula directly, you can take any zero reference to calculate height. Okay, I'll just do one example for you. So say in this case, okay, so in this case, if you see, I've got this blue line here as the zero reference. Okay, what am I trying to say? Give me a second. So this is the x-axis, right? This is the y-axis, and now we have a reference axis here, a zero reference. So this zero reference would be considered as h is equal to 0. This zero reference would be considered as h is equal to 0. Now, this point A, the gravitational potential energy at point A would be equal to m into g into height of this point A with respect to zero reference. What is the height of A with respect to zero reference? Since they are on the same line, the height with respect to zero reference is equal to 0, and therefore this value is 0. Similarly, when it comes to C, what is the gravitational potential energy at C? it is equal to m into g into height of this point C with respect to the zero reference. And where is C located? C is located exactly on this zero reference, and therefore the height is also equal to 0, and therefore the gravitational potential energy can be assumed to be 0 here. Now at B, what is gravitational potential energy at B? It will be equal to mass into g into height of this point B with respect to the zero reference. And with respect to zero reference, this height is h max, and therefore GPE should be equal to GPE max. Okay. Now, of course, this is a very basic thing. Now, what I want you to do is, I want you to solve the same question by keeping the reference axis as a line passing through B. What will you do? You will redraw this question, you will redraw this diagram, right? And you will take the statement like this. By considering B to be the point through which the zero reference passes. So this is your zero reference now. This is your zero reference. And you will do this calculation with respect to this zero reference, and then tell me how will the value vary for GPEA, GPEB, and GPC, and what will you be your conclusion. Okay. Okay, so having said that, let us now move on to the last section. So here the statement says the horizontal component of velocity is 0. The horizontal component of velocity is 0 at highest point. In a projectile motion, if you ignore the air resistance, the horizontal component of velocity will always remain constant throughout the motion. Something that we're discussing right from the first diagram. So say if this object is projected at the velocity u, right? Velocity u, there will be two components. One is the horizontal component, and the other would be the vertical component, right? And the horizontal component would remain the same. Horizontal component would remain the same throughout the motion. Okay. The horizontal component does not become 0 at the highest point. Instead, what becomes 0 here? What becomes 0 here is the vertical component that becomes 0. The horizontal component does not become 0 at the highest point. It stays the same as it was at the launch. Therefore, D is also incorrect. So we have the correct option to be option C. Okay, so okay, now since let me just take one more second to explain this one. So since there is no force along the x direction, right? Since there is no force in the horizontal direction, mass into acceleration in the horizontal direction would be equal to 0, or in other words, acceleration in the horizontal direction would be equal to 0. And since ax is equal to 0, what is vx is equal to? Vx will be equal to ux, which means the final velocity will be equal to initial velocity throughout this projectile motion. Okay. Okay, so that's it. This question. I would request you to make a note of this. Okay, write this with me for one time. See, this will take a long time to explain. So say I have taken somewhere around 15 minutes to explain this. When you make a note of this, it will take you almost the same time. But once you have done making the note of this, once you have written it on your own, once you have solved this question by understanding the concept, the coming questions would take only 3 or 5 minutes, or maybe even less than that. Okay. So the point is always focus on which concept is being demanded in the question. What is the question paper setter trying to judge you in that question? What's the concept that he's trying to evaluate you on? Okay. So since this was basically not something based on this chapter, it was based on a question from work energy power, but it was intended to check your concepts on projectile motion. Okay. All right. Now moving on to the next question.